DataStores, SQL stores. Overview. Description. SQL structured query language stores, also known as relational databases, store data in structured formats using tables. These databases use SQL for defining, querying, and managing data, ensuring data integrity and consistency through schemas, relationships, and transactions. Key components. Tables. Description. Structured collections of related data organized into rows and columns. Each table represents an entity, with columns defining attributes and rows representing records. Schemas. Description. Definitions of the structure and organization of the database, including tables, columns, data types, and relationships between tables. Indexes. Description. Data structures that improve the speed of data retrieval operations by providing quick access to rows in a table based on the values of one or more columns. Queries. Description. SQL statements used to perform operations on the data, such as select, insert, update, delete, and join. Transactions. Description. Units of work that are executed as a single, atomic operation, ensuring data consistency and integrity through properties like acid atomicity, consistency, isolation, durability. Steps. Step 1. Description. Define schema. Create a schema to outline the structure of the database, including tables, columns, data types, and relationships. Step 2. Description. Create tables. Use SQL commands to create tables based on the schema definition. Specifying columns, data types, primary keys, and constraints. Step 3. Description. Insert data. Insert records into the tables using insert statements, populating the database with data. Step 4. Description. Query data. Retrieve and manipulate data using SQL queries. Perform operations like select, join, where, and order by to extract relevant information. Step 5. Description. Manage transactions. Use transaction control commands like begin, commit, and rollback to ensure data integrity and handle concurrent access. Considerations. Scalability. Description. Design the database schema and indexing strategies to handle large volumes of data and high query loads efficiently. Performance. Description. Optimize queries, indexing, and database configurations to achieve fast data retrieval and manipulation. Security. Description. Implement access controls, authentication, and encryption to protect sensitive data. Backup and recovery. Description. Regularly back up the database and implement recovery mechanisms to prevent data loss and ensure data availability. Technologies. Relational Database Management Systems (RDBMS). Description. Software systems that manage relational databases and provide tools for defining, querying, and managing data. Examples: MySQL, PostgreSQL, Microsoft SQL Server, Oracle Database. Vector stores. Overview. Description. Vector stores, also known as vector databases or vector search engines, store and manage high-dimensional vector embeddings for efficient similarity search and retrieval. These databases are used in applications like image search, recommendation systems, and natural language processing. Key components. Vector embeddings. Description. High-dimensional representations of data, e.g., text, images generated using embedding models. These vectors capture the semantic meaning of the data. Indexes. Description. Data structures that facilitate fast similarity search operations by organizing vector embeddings. in a way that allows efficient nearest neighbor search. Query engine. Description. The component that processes search queries, finds the most similar vector embeddings, and retrieves the corresponding data. Storage. Description. The underlying storage system that holds the vector embeddings and associated metadata. This can be in memory storage or persistent storage. Steps. Step 1. Description. Generate embeddings. Use embedding models e.g. BERT, ResNet to convert raw data into high-dimensional vector embeddings. Step 2. Description. Index embeddings. Create an index for the vector embeddings to enable efficient similarity search. This involves organizing the vectors using techniques like KD trees, locality-sensitive hashing LSH, or approximate nearest neighbor AND methods. Step 3. Description. Store embeddings. Store the vector embeddings and associated metadata in the vector store, ensuring efficient access and retrieval. Step 4. Description. Perform similarity search. Use the query engine to perform similarity searches, finding the nearest neighbor vectors to a given query vector based on distance metrics like cosine, similarity, or Euclidean distance. Step 5. Description. Retrieve results. Retrieve the data associated with the nearest neighbor vectors and present the results to the user or application. Considerations. Accuracy. Description. Ensure that the similarity search returns accurate and relevant results by using appropriate embedding models and indexing techniques. Performance. Description. Optimize the indexing and search algorithms to achieve fast query response times, especially for large-scale data. Scalability. Description. Design the vector store to handle large volumes of vector embeddings and high query loads efficiently. Storage efficiency. Description. Manage the storage requirements by using compression techniques and efficient data structures to store vector embeddings. Technologies. Vector databases. Description. Specialized databases designed to store and manage vector embeddings for similarity search and retrieval. Examples. FAISS Facebook AI Similarity Search. Annoy Approximate Nearest Neighbors OER. Milvis. Pinecone. Example usage. SQL stores. Application. E-commerce platform. Use SQL databases to store and manage product information, user data, and transaction records, enabling efficient data retrieval and reporting. Application. Banking system. Implement relational databases to manage customer accounts, transaction histories, and financial records, ensuring data integrity and security. Vector stores. Application. Image search engine. Use vector stores to store image embeddings and perform similarity searches to find visually similar images based on a query image. Application. Recommendation system. Implement vector databases to store user and item embeddings, enabling personalized recommendations based on similarity search and collaborative filtering.